So in this video we're going to look at solving one-step equations. So first let's get an overview of what the steps are to solve a one-step equation. So for the first step, let's just say step 1, we want to find our variable. And we'll look at that in a second, but for now let's just make a note of that. We want to find our variable or identify our variable. All right. Step 2, we want to move anything that's not our variable. So move anything that's not the variable to the other side of the equation. All right. And then we're going to use inverse operations or opposite operations to do that. So once again, find your variable, move anything that's not the variable to the other side, and you're going to use inverse operations to do that. So now let's take a look at what inverse operations actually are. All right, then we'll do some examples because this will get a little bit easier. So now these are the 4 operations we're mainly going to see right now to begin with. We have adding, subtracting, dividing, multiplying. Now, to use inverse operations, you have to know what are inverse operations. And adding and subtracting, those are opposites or inverses. Okay, I'll just say opposites right now because it's a little bit easier to understand. Okay, so adding and subtracting are opposites. So is multiplying and dividing. All right, now let's try to put all this together and go through an example, and then I bet you'll be able to do some of these on your own. So let's look at a quick example. So let's say we have m plus 12 equals 10. Okay, now our job, the directions would say something like solve for m, or it may even just say solve. Okay, but we want to solve this equation. Now, it's a one-step equation because we can solve this equation in one step. So the first thing we want to do is identify our variable. Our variable is m, and we actually want to do something with this, and you'll hear this a lot, so I'll just go ahead and write it. You want to isolate your variable, which means you want to get it by itself on one side. So by itself on one side. Okay. Now, in order to do that, let's look at a quick trick to look at both sides. Because when I say both sides, you're probably thinking both sides of what? And it's both sides of the equal sign. So a quick trick is to do this. Go to the equal sign and draw a line. So now you can see there's a left side and a right side of your equation. So what we want to do is get this m by itself on this left side, which means, well, you answer. What has to move? What is left over once we say, okay, we're going to isolate this m? What else is on that left side? And it would be plus 12. So plus 12 needs to move. We need to move plus 12 to the right side. Now, how do we do that? That is going to depend on what is happening in between m and 12. So a question you're going to ask yourself is, what's happening in between my variable and my number that I want to move? And in this case, it's addition. So if you want to get rid of addition or adding 12, you're going to do the opposite operation. So if you remember, what did we say the opposite of adding was? It's subtracting. And if we add 12, the opposite of adding 12 would be subtract by 12. So this, if you notice, 12 minus 12 is just going to equal 0. So all that's going to happen is this will cancel. M is going to come down by itself. And then we could say m equals 10, but that's not correct. But for now, you can see how we got this m by itself. Since we were adding 12, we subtracted 12 to cancel out this 12 on the left. Now let's just do a quick example or a quick visual real quick. Let's say I have a seesaw. Okay, we all know what that looks like. 2 people get on each side and it goes, up and down. Let's say I were to drop a 20-pound stone on this left side. Okay. Now, what would happen if I did that but didn't do anything to the right side? We all know this would go down, this part of the seesaw would go up, and then it would no longer be balanced. Okay, so what if I said balance the seesaw? What would you do to the right side? If I added 20 over here on the left, what would you have to do on the right to make it balanced? You do the same thing. So there's going to be a 20-pound weight on either side, which means this is now balanced. Essentially, here's what we established. What we do to one side, we have to do to the other, and our equation is just like the seesaw. We want a balanced equation. So if I said balance this equation, we did minus 12 on the left, so what do we need to do on the right to make this balanced? We subtract 12. So what you do to one side of an equation, you have to do to the other side. And now 10 minus 12 gives us our answer, which is m equals negative 2. All right, now let's make a note here for a second so that we can use it moving forward. Actually, let's do that after we do the next example. All right, so let's do another example. Let's try a different setup. Let's do negative 2 equals g minus 9. So see if you can do this one real quick. All right, now let's see if we can follow our steps. First, let's identify the variable. The variable is g. Now, g's on the right side, but it doesn't really matter here because we're just trying to get g by itself or isolate it. So now, let's cut our equation in half. Let's look at the left side and the right side. So the right side has g. So what's left over on the right side? Once we say, okay, g's not going to move, what's left over that we need to move? That would be the 9. And if we ask ourselves, well, what's happening in between g and 9? It would be subtraction. So we need subtraction's opposite operation to do this. So what's the opposite of minus 9? It would be adding 9. So we're going to add 9 to the right side. And negative 9 plus 9 is equal to 0, so that's going to cancel. G comes down by itself. Now, I could say negative 2 equals g, but that is incorrect. Because what did I not do? Which you could probably tell me. I didn't balance my equation. So if I added 9 on the left or on the right, I need to add 9 on the left as well. And now negative 2 plus 9 is going to equal 7. So 7 equals g. There is my answer. And I bet you could do that one on your own. Now, let's make a quick note. You've heard me say this twice now. I've said the word cancel. Okay, I've said things cancel out. When you're doing either addition or subtraction, canceling actually means that it's going to end up equaling 0. Now, watch what happens when I multiply or divide. And I'll actually tell you just so you can write it down real quick. When you multiply or divide, canceling actually means equals 1. So let's look at an example of that so you know I'm not just making stuff up. All right, so let's say, let me find a good example. Negative 7y equals negative 91. Now, see if you can do this one on your own. Because, I mean, let's say you do it and you get it wrong. Who cares? We're just practicing. So see if you can do it, and then we'll look at it together. So once again, let's look at both sides of our equation. Actually, let's first just, what's the variable here? What are we trying to solve for? Because the problem's going to say solve. We're solving for y. So we want to get y by itself. Now let's look at both sides of my equation. I have a left side, which is negative 7y. The right side's negative 91. So the question becomes, what's happening in between negative 7 and y? Because here's what I see a lot of people do. They'll say, okay, if I want to move negative 7, I just add 7. That cancels. We're good to go. But that's not actually true in this case because we need to look in between negative 7 and y. And when you have a coefficient and a variable glued together like this, negative 7y, it's actually glued together with multiplication. This is negative 7 times y. So the opposite operation of multiplication is division. So we're going to divide to get rid of negative 7. Now, pay attention to this. Our entire coefficient is negative 7, which means we need to divide by negative 7, not just 7. A lot of times I see students just bring down 7, divide by 7, and they move on. But you have to make sure you divide by the whole coefficient, which is negative 7. Okay? And we're going to do that on both sides so that we're balanced. Now, watch what happens. If I did -7 divided by -7, is that 0 or is it 1? It's 1. But these still will cancel. These two -7s will still cancel, because if I write this as 1y, it's just y. We don't have to write the 1 in front of y. It's understood to be there. So once again, division or multiplication cancels to give you 0 or 1. Adding and subtracting cancels to give you 0. All right, and now what we do to one side, we do to the other. So -91 divided by -7, two negatives when they divide makes a positive, so those two are just going to go away. 91 divided by 13, or 7 is 13. And there's our answer. So now let's look at one more, the last case. And I bet by now you'll probably be able to do this one by yourself, but let's look. All right, so let's say we have x over 9 equals -4. So try to do this one on your own. Now, once again, let's identify the variable. It's x. X and 9 are on the left side, so this 9 needs to go. Okay, we need to get x by itself or isolate it on one side. So 9 needs to move over here to the right. How do we move it? What's happening between x and 9? And if you ever see a fraction, it's the top divided by the bottom. Or, I mean, you've probably seen numerator and denominator. So numerator divided by denominator, which I'm not going to write all those out because I'm a little lazy. All right, so we're dividing by 9, so what's the opposite of dividing by 9? Well, the opposite of dividing is multiplying. So if we want to get rid of that 9, we're going to divide by 9. And we're going to do that to both sides. And now, if I do 9 divided by 9, it just cancels to give me 1. So x comes down. Once again, we could say 1x, but we don't need to. And then all we have to do is -4 times 9, and we're finished. So a negative times a positive is a negative. 4 times 9 is 36. So x equals -36. All right, now let's just look at something real quick. Let's say I did this problem and I want to know for sure that -36 is my answer. If x is equal to -36, that means I could take -36 and plug it in for this x, and my problem should be equal on either side of the equation. So let's see if that happens. So now instead of x, we're going to plug in -36 divided by 9 equals -4. So is that true? Well, what's -36 divided by 9? It's -4. So that's true. So if you want to check your answers, it's very simple. Just plug in the value and replace the variable with that value, and then make sure your problem still ends up being the same. Or you need the equation to be true once you do that. So let's recap real quick. The big takeaways are this. The steps are, once again, you want to identify your variable. So identify variable. Then you want to move anything that's not the variable. So move anything not variable. And then last, you're going to use inverse operations to do that. So use inverse operations or opposite operations. And last, well, let's review one last thing. What are the inverse operations? So real quick, adding, subtracting, those are inverse operations. Dividing, multiplying, those are inverse operations. As long as you can remember those, that's your ticket to solving one-step equations.